Welcome to our explainer. Today, we're diving into something we see all the time, but maybe don't fully understand: fire. From a tiny candle flame all the way up to the powerful engine in a car, it's all driven by the exact same incredible chemical reaction. So, let's get into it.
First things first, let's tackle a really common question. We use the words burning and combustion pretty much interchangeably, right? But in the world of science, are they actually the same thing? The answer might just surprise you. To figure that out, we have to uncover the fundamental secret behind every single fire. And it all starts with understanding the difference between two really basic types of change in the world around us. Okay, so look at the difference here. A physical change, like ice melting into water, is really just a change of state. The substance itself, H2O, is still H2O. But a chemical change, like burning, that's a total transformation. The atoms literally get rearranged to create brand new substances. And as you know, you can't just unburn a piece of wood. It's a one-way street. And that powerful chemical change has its own scientific name: combustion. At its core, it's a high-temperature reaction where a fuel, let's say wood, rapidly combines with an oxidant, which is usually just the oxygen in the air, to release a massive amount of energy as heat and light. Now, for any combustion to happen, you need three essential things. Think of it like a recipe. We call it the fire triangle. You need a fuel to burn, you need oxygen to react with it, and you need enough heat to get the whole reaction started. That's called the ignition temperature. If you take away any one of those three things, the fire goes out. It's really that simple.
So this brings us right back to our original question. Here's the deal. All burning is combustion, but, and this is the key, not all combustion is burning. The big difference is the flame. Burning is just the word we use for the kind of combustion that you can see, the kind that produces that visible flame. Other types, like the smoldering of charcoal, well, they're combustion, but they're not really burning in the same way.
Okay, so this is where things get even more interesting. When we start looking at how things burn, it turns out that the whole process, everything from the color of the flame to how safe the reaction is, it all boils down to one critical factor: how much oxygen is available. With plenty of oxygen, you get what's called complete combustion. It's clean, it's efficient, and it produces a really hot blue flame. You've seen this on your gas stove, right? The only things it creates are harmless carbon dioxide and water. But if you limit the oxygen supply, you get incomplete combustion. And that is a dirty, inefficient process that creates a cooler, yellow-orange flame, like a candle's, along with some pretty dangerous byproducts.
And this is why it matters so much. Incomplete combustion is what produces carbon monoxide, a toxic gas you can't see or smell. It also creates soot, which is that black, smoky stuff that's basically just unburned carbon. So not only is it dangerous, it's also a huge waste of the fuel's energy.
All right, let's see how all this science actually applies to our everyday lives. You might not realize it, but combustion is one of the most important chemical reactions that powers our modern world. You interact with it all the time.
I mean, really think about it. The internal combustion engine in your car is just harnessing thousands of tiny, controlled explosions of gasoline vapor every single minute. The natural gas in your stove that cooks your food, that's the complete combustion of methane. And for centuries, our entire civilization has literally been built on the energy we get from burning fuels like wood and coal.
But this brings us to another little puzzle. You've definitely seen a candle burn with a bright, flickering flame, and you've seen charcoal in a barbecue just glow that menacing red-hot color. They're both undergoing combustion, but they look completely different. So what's going on there? The answer, believe it or not, comes down to one single word: vaporization. It's all about whether the fuel turns into a gas before it actually combusts.
Let's break this down. For a candle, the solid wax first melts. Then it gets drawn up the wick as a liquid. And finally, the heat vaporizes that liquid into a flammable gas. It's that gas that's reacting with oxygen to create the visible flame. But charcoal, totally different story. It doesn't vaporize. The solid carbon on its surface reacts directly with oxygen. We call this flameless combustion smoldering, and we see it as a glow.
So understanding how these fuels burn differently is super important because the stuff that gets produced, the byproducts, can have huge consequences. As useful as combustion is, we really have to be aware of the risks, both to our health and to the environment.
The most immediate threat is definitely carbon monoxide. When you breathe it in, it actually messes with your blood's ability to carry oxygen. Even low levels can give you headaches and make you dizzy, while high levels can be fatal.
This is precisely why proper ventilation and carbon monoxide detectors are absolutely non-negotiable when you're using any fuel-burning appliances inside.
And then, on a global scale, the problems are just as serious. High-temperature combustion can create nasty things like nitrogen and sulfur oxides. These gases can mix with water in the atmosphere to form acid rain, which is terrible for our forests and lakes. They also help create the smog that hangs over our cities.
Whew, we've covered a lot of ground, I know. So let's just boil it all down to the 5 most important takeaways from all of this. You can think of this as your combustion cheat sheet.
All right, here are the key points to remember. Number 1, the fire triangle. You always need fuel, oxygen, and heat. Number 2, burning versus combustion. Burning is just the type of combustion that makes a visible flame. 3, complete is clean. With lots of oxygen, you get a clean reaction. 4, incomplete is toxic. That's what happens when oxygen is limited. And number 5, flames mean vapor. A flame is a sure sign that the fuel turned into a gas before it burned.
So there you have it, the science of combustion. It's the reaction that has literally powered human progress for thousands of years, but its side effects also present some of our biggest challenges today. And that leaves us with a really profound question to think about. As we look to the future, what's going to power our world? Thanks for watching.